Hello, my name is Ghada Dushaq. I'm a Palestinian scientist working in photonic research lab at New York University. On November 9, 1989, I was 1 year old. As a child, I was fascinated by how nature works, specifically light, optics, and what are these materials made of. Basically, to be a scientist, and I think this dream came true. I'm breaking the wall of high-speed optical communication. Let me explain. Optical communication system consists of three major parts: transmitter, optical fiber, and receiver. Let's say you want to send a message. Then this message will be transmitted from the transmitter through the optical fiber to the receiver part, where most of my research is. I focus on a very special components called photodetectors in the receiver part. Photodetectors, as the name suggests, they are ultra sensitive to light and they are taking the optical signal back to the electrical domain, which is the language that our devices can understand. Typically, these photodetectors are made of materials such as germanium and the 3,5 compound. However, these materials, they can't accommodate for the high ever increasing demand of high-speed communication. They are always suffering from a trade-off between ultra sensitivity and high speed. Therefore, my solution focus in innovative and new emerging materials that can boost the current performance of optoelectronic devices. My research focuses on new emerging materials called 2D materials. These materials, they are atomically thin. They can be in a stone form, and then we exfoliate them using a scotch tape. So they can be atomically thin layer. Maybe the most famous form is graphene. However, I'm focusing on a germanium-based 2D materials because these materials, they show phenomenal optical properties in the telecom band, where my research focus is in fiber optics communication. So we focus on the telecom band wavelength. Our findings so far show that this material can show photoresponsivity to light in the telecom band up to 30 times higher than the standard material used currently in the silicon photonics. The ever-increasing demand for high-speed communication motivates all researchers to look into new components and new materials and new designs to boost the current performance. Germanium-based 2D materials still is a very new field. Therefore, there are many questions still we need to answer regarding their chemical stability, data reproducibility, and the integration process. So it's a long-term project which actually needs a lot of research to be in the production line.